Hello everyone, I am Mohit, a third year BTech student from IIT Roorkee, and in this video I am going to discuss an experiment from our applied instrumentation lab. The experiment is to determine the speed of a rotating body using an electromagnetic pickup. So let's jump on the practical part now. So this is the trainer kit that we are going to use for experiment. We have connected three different devices with this trainer kit. First is the multimeter to determine the voltage that we are giving to motor. Second is this motor, and third is this digital oscilloscope to determine the multiplier frequency. So first of all, we have used a DC motor for our as our rotating body, and we have connected a disc that has 15 slots attached to the axle, so that whenever the motor rotates, all these slots their link change with the proximity sensor, so that we can get the pulses according to the revolution speed of the motor. So here is the reading that we are getting from the proximity sensor. The sensor then converts that reading into a wave according to the pulses that they are generated. That wave are fed to the wave shaper that converts the wave into a square wave, so that we can get the frequency more accurately. And then we have a multiplier, because currently if you see there are 15 slots in the disk. That means if we rotate the disk, we will get the pulses accordingly. The more the more we rotate, the higher the pulses we get. This is the frequency. Now the task of multiplier is to multiply the wave shaper frequency by 4, so that we can get 60 pulses in one revolution. And we have connected this multiplier with a 1 hertz clock, so that when we measure the frequency, we can actually get the RPM speed of the motor using this toggle switch. So we have to take two different readings for our experiment. First is the RPM reading, that we are going to take just by first of all, let's rotate the motor. So here we are giving the voltage to the motor, and we can see that voltage here, DC voltage. So as you can see, because of the inertia, it took some voltage to actually rotate. Yeah, so let us keep it to 1.8 volt. Yeah, so now you can see the motor is rotating, and here we are getting the RPM of the motor, but actually we have to calculate the speed from ourselves. So this is just for the verification purpose, and this we can also see in the oscilloscope. uh, if we measure the multiplier frequency, you can see the value is approximately 620 hertz, and the same we can see in the RPM reading of the trainer kit as well. So we can expect that the RPM speed of motor currently is 620 RPM. The motor is rotating at 620 RPM, but this is just for the verification purpose. Now we have to calculate the actual speed of the motor. So for that, what we're gonna do, we're gonna first of all toggle this switch to speed, and then we're gonna reset, and then we have to press this button to actually count the number of pulses for a specific duration of time. So let us count the pulses for we can remove this as we have no use of this. Yeah, so let's start counting now. Yeah, so you can count for any amount of time you want. Let us keep it to this. Yeah, so this is our time, and these are the number of pulses that are generated in this time. So we have noted down the number of pulses generated, and we also know that there are 15 pulses that will be generated according to this disk. So now we have two different datas. One data is of the RPM speed, which is directly given by the trainer, and second is the data of pulses that are being generated within a specific amount of time. Also, we know the radius and the number of slots within the disk. That means we can calculate the distance constituted by one pulse along the circumference. And if we multiply this distance uh, with the number of pulses per time, we can calculate the speed of the motor. And to verify this speed, we can convert the RPM speed into centimeter per second or millimeter per second, whatever units we would like to take, with the actual speed, and get the error that will be approximately 5 to 6%. So this was from my side. Thank you